Hello everyone, my name is Yogesh Punia, and today in this episode we shall be expanding our discussion over the world of electrostatics. In the last episode we have discussed what are the basic electrostatic concepts, that is, what are electric charges, the type of electric charges, their properties, how do they behave and how do they affect each other when they are brought in each other's surrounding. We also learnt about the concept of electric field. To have a quick review, I go by saying that electric field is some sort of a mysterious force that is brought about by the charge that is taken into consideration to some other charge that is brought near to it. So, today in this episode we shall expand our knowledge over the electric fields and we will discover some of the newer yet exciting concepts of the field called the electrostatics. Until now, what we have discussed the qualitative aspects of electric field lines. I mean, if you say that what are electric field lines, then I will say, okay, I have got a charge and the amount of electric lines of force that is going out of it, if it is a positive charge, makes some sort of a field around it that I can denote by the electric field lines. But that is only a qualitative aspect. Now, as a physicist, I must know what is the quantitative aspect of it, means how does it quantify its presence. Suppose if you have got a charge and you want to know that okay, this is the qualitative aspect of it, but you are not knowing the quantitative aspect, then it is of no use. So, we will start our discussion with the quantitative aspect. That is, suppose you have got a pipe in your hand and your parents say, okay, go into the garden and water the plants. Now, suppose this is the pipe I am holding. Now, since it is a pen, we have to assume something. If this is a pen or a pipe with which I am watering the plant, what will happen is that if I am holding it like this and I have a plant here, so the water will come like this, in this way. But suppose I get bored watering the plant in this way and I simply hold it like this. Now, what will happen? The water has to go downwards, but it will go like this. The best thing that we should observe is not that the water is going to the plants, but we should observe that how the water is going out of the pipe that we are holding. That means the cross sectional area or the way in which I am holding the pipe matters the most. There is also a very good example of it, but I can't do it. That is, if I squeeze this pipe, then you will see the amount of water coming out of it after squeezing it is totally different from the amount of water that I am getting without squeezing it. Since I can't squeeze this pen, you can simply do it in your home. If you want to know that how will it affect the quantity of water, you can simply do it at home and then you will see that if I do not alter the cross sectional area, the more amount of water is coming out, and if I simply decrease the cross sectional area, the less amount of water will come out. This is only some sort of our classical analog in our day-to-day life, but for a physicist who is dealing with the electric charges and how many electric field lines are coming out of it, he says that just like the water coming out of this pipe, I can think of some mysterious quantity that is called flux. Yes, the number of field lines that come out of a particular area that I am taking into consideration is known as the flux. So, if you are to find out how much flux is coming out of some particular area that you are taking into consideration, what you have to do simply is that you have to take a charge, consider an area that you are interested in, and then you will find out that the way in which you are inclinating it will affect the amount of flux coming out of it. Now, if you want to know further that how this electric flux matters with the area of cross section or the area that you are taking into consideration, you can do a very simple example. But you should have three things that I bet you will have. The things are one torch, one any rectangular or circular area that you can simply cut through a piece of paper or a cardboard, and also a wall that you all have. So what you're going to do is simply switch off the light so that you can see it really nice. Like suppose I have this torch, and this is the cupboard piece, or the any sort of piece that is a rectangular piece, or the what you call circular piece that you want to take. That's all your choice. Physics will roll according to you. And this is the torch that you take into consideration. Now you simply switch on this torch. So what will happen is that some amount of light will come out of it, and a sort of projection will be formed on the wall. Now if I want to do some mischief around here, or if I want to play with it, what I will do is I will simply tilt it like this. So when I would tilt it, you can clearly see earlier it was like this. So if I take that thing into consideration, this is the light. If I am taking a simple pen like light shape coming, but when I tilt it like this, can you see a difference? The difference is that the orientation has changed, and now when I do it like this, it will close the pen. Actually it will simply have an obstacle there for the light, and the amount of light that is passing through it will change, and you can see this difference clearly when you can go for the projection that you will see on the wall. So in this way you can clearly see that the orientation of the planar area that you are taking into consideration matters a lot for the electric charges, just like the pipe and the water example. Now I am going to tell you one more example that will clearly show you how this area is changing, or how this angle is changing, why the shadow is changing when I am moving the planar area to, say, suppose from this to this, this to this. Means there must not be any difference. If I take my hand as an obstacle, it should be same for the light, but the orientation of the hand is making all the difference. Now so here we go for the example. Suppose I have got a point here, and I say that my light that is from the torch is going in this direction. If I keep my that area that I am taking into consideration, that is the piece of say some cardboard or some paper, in suppose this direction, so what will happen is that there will be some difference angle between this light that is going through this and the area that I have kept here. Now this is not a way to define it. How will we define it? The definition comes from here. If I move this piece to this point, and say suppose I have got this cardboard here, so what will happen is there will be some sort of obstacles that will be sensed by the light, and hereby at this screen you will see something. Now if I want to cut it and to show it to you that how it will change the angle and how the angle will keep on increasing and increasing, I can simply draw a thing. What I will do is I will imagine that I have got this area of cross section here with me, or if you want a better example, what we will do is we will draw another figure. What we will do is, this is the electric charge I am having, and this is, say, suppose the circular cross section that I am considering. So suppose if I take into consideration only the two lines of force or the two electric field lines coming out of it, so I will get it like this. Now as I go on increasing it, or as I go on following it, what will happen is that its magnitude will change. It will get broader and broader and broader. So if I take this angle as theta, what I will see that this angle will matter the most, and with this planar area that I have taken, that is the circular area, if there is a charge here, it will keep on expanding like if you have got a cake, and if you cut the cake in some certain angle, then the friend that is standing behind you, or the friend that is standing before you, will be really very angry and happy respectively to you. Now how is that? The friend that is standing behind you will think that you are giving him less share, but the friend standing before you will see that the cake or the size of the cake that you are cutting is slowly keep on increasing like this. So he is thinking that I will get this share, the increased share, that is I am showing you by this, and the friend that is standing behind you will think that he will only get with this much, that is this area that I showed you. This is what happens with the electric flux. Electric flux really gets angry when you show him a very small cross sectional area. So the more you increase it or the more it expand it, electric flux, the orientation of it changes. But here is a word of caution. Please do remember that what we have discussed about electric flux. We have discussed that there we have some electric field, suppose E, and we have this cross sectional area, that is delta S, or if I go here, this is the delta S. Now what is electric flux? The electric field lines that are coming out of a particular planar area. So if I go for this definition, I define something as phi, which is known as the electric flux, which will depend upon E times delta S. So this is what we have got, phi equal to E dot ds, and if I go for the dot product, then it is E dot delta S of the cos of the angle between the orientation of the planar section, that is some spherical section or some rectangular section, and the electric charge and the electric field lines coming out of it. So this is the theta. This theta has got everything that has to do with it. Means this theta is the master that controls the electric flux. So now what we have discussed recently is that the electric flux is a very mysterious quantity that comes into play whenever a planar section or the area of cross section comes into play against an electric charge. How the orientation of this electric charge is affected by the planar section, how the electric field lines adjust themselves to give out the constant electric flux lines. Please remember this, the electric flux is always constant. Actually what will happen is, if we increase the cross sectional area, the electric field lines will adjust themselves, the density will matter the most. So flux is always constant no matter how far it spreads. So now what we have discussed today? We have discussed a very important electrostatic concept, that is the concept of electric flux. That is, if I go for our classical day-to-day example, if I am watering the plant, my orientation of that pipe or my way of holding the pipe will matter the most. That is, if I squeeze it, lesser amount of water will come out of it, and if I leave it as it is, the more amount of water will come out. Then we saw a shadow example, that is with some power source or some light source, and I have got some restrictions, that is the planar sections of say paper or cardboard, and I had the projection over the wall. And then we saw how the orientation when we change it, that is the angle when we change it, matters in the form of the projections. So in the coming lectures we shall be discussing how this concept of electric flux has got a great influence in the world of electrostatics. How does it affect each and every parameter that is around us, and how it is really beautiful yet exciting. Till then, take care of yourself, and yes, ponder over all the thoughts that you find in the world of physics. Thank you.